listeners, what a special day. We are here celebrating the 100th episode of Connect Over Coffee. What an incredible journey it has been over the last 4 years, bringing you these 100 episodes. I was just reading through some statistics on podcasting and just wanted to share this with you that 90% of podcasts, it says, that don't get past episode number 3. And of the remaining 10%, 90% don't make it to episode 20. So it goes on to say that if you get to episode 21, you are in the top 1% of episode producers. Now, we have gone past 20 episodes multiplied by 5. We are celebrating 100 episodes of Connect Over Coffee. Over the last 4 years, I have grown not only in years, but also in knowledge and empowerment in talking to all our experts that have come to our sessions and have given their knowledge so freely and have just talked to us about all the latest and the greatest insights happening in the ovarian cancer space for the past 4 years. Not just the doctors and the experts, but it is because of you that we are here today. Thank you for listening. Thank you for sharing. Thank you for asking those brilliant questions that keep us inquisitive, that keep us curious, and help us talk to our doctors about what is happening in the ovarian cancer field that we need to know about. What is it that we need to bring to you so that you are empowered to ask the right questions to your healthcare team and providers when it comes to your treatment, your diagnosis, your survivorship, side effects, just name it all. So if you have benefited from this particular series, I would welcome you to send your comments and type in your comments in the chat section below or in the comment section. And we would be so grateful to learn how this series, the past 100 episodes or however many you have watched, have helped you grow, not only in terms of your knowledge, but also in terms of your understanding of ovarian cancer. What are the challenges? What are the new things happening? What are the gaps? So I invite you to please use the comment section to keep your comments flowing, give us your congratulations, give us your best wishes, because without that, we cannot proceed forward. I know that with your blessings, we have come this far. We'll do another 100 episodes with your blessings. So please add to it. Go to your comment sections. And so also, because this is our milestone episode, we are also giving away some surprise gifts to everyone or anyone that will comment on the Connect Over Coffee series. We have 100 giveaways to give for the 100 episodes. So quite many, but it will also go very fast. So make sure you put in your name and also any comment that you have in terms of how you have benefited from the Connect Over Coffee episode or episodes. And a big shout out to GSK for helping us and believing in our mission, and also sponsoring each and every episode of Connect Over Coffee since our inception. We started during the times of COVID, and our thought was we'll bring this information to you while we are all stuck at home. And here we are 4 years later, we are still going. And a big, huge shout out to the GSK team and the company for helping us move forward and share this vision and the information with all of you. So we started 4 years ago with our first episode guest who kicked us off. And of course, to make it extra special, we have brought in the same exact episode guest that we started 4 years ago with to share this special milestone episode with you. So if you're with me, we'll just bring him in right now. Hello, Dr. Coleman.
Hey, you're looking great. So good to see you.
We are live and we are recording while you're here. So I was just sharing with our audience and our followers that 4 years ago, you started this kicked us off. The first episode was with you, believe it or not.
Oh my gosh. Yeah, I didn't realize that was so special. Thank you.
Not only a special milestone episode, but it is extremely special to have you with us back back to the 100th episode. So that
Oh
is,
my gosh.
thank you so very much for making your time to be with us today.
It's such a pleasure, and thank you for what you're doing. It's so important for all of us to hear that voice, and what a joy it's been. I feel like we should have a cast party or something.
Yes, we will get to that eventually when all your travel plans end.
I
So,
know. Gosh. Oh, it's
so
so great to
Dr.
see you.
Coleman, I'll delve right into it.
Mhm.
We have a lot to chat with you today because it's our 100th episode and it's extremely special. So we started, as I said, the Connect Over Coffee with you 4 years ago. Now we are on our 100th episode. So how has the science in ovarian cancer progressed in the past 4 years since the first episode that you and I did? And what have been the major milestones and advancements that you would like to tell us about since our first episode aired in 2020?
Yeah, it would be great to go back and listen to that. I think that, the time frame for, gigantic therapeutic advances takes this amount of time. So I bet that a lot of what we discussed 4 years ago were basically we're on the cusp of data reading out and from these large trials that took, a couple years to enroll and waiting for the events to occur so that we could actually decide whether or not this was a good therapy or not. I think probably the more rapid pace has just been the science. There's been so much discovery work being done, and probably the most visible change has been in the GYN space has just been the understanding of how immunotherapy, for instance, works and doesn't work in certain cases, why that is, and then a lot of our hypotheses that were under evaluation back 4 years ago. Now some of those have now read out, and so we've kind of learned from that, and then continue to move on. That we talk about the iterative process of discovery, hypothesis generation, and then testing, and then that usually then raises new hypotheses and leads to new discovery, and no current trials. I remember about 4 years ago, we were dealing with a lot of the movement in ovarian cancer with the PARP approvals. We had a lot of successful trials, and then at that time, there was maturing overall survival data in the recurrent setting that was coming. And so we were, awaiting that. Some of that information was starting to leak out. And it caused, some of the retractions in those indications that was, we spent the last 4 years basically fighting, trying to find its home. But we also, at that time, also were anticipating a number of immunotherapy trials that were coming in ovarian cancer, and for the most part, those told us a different story about what ovarian cancer is. And I think we spent the last 4 years kind of understanding what it is about ovarian cancer that's different from, say, lung cancer or melanoma, breast cancer. So I think on the clinical side, things have kind of iteratively moved along. We've had new trials come, new trials go. We've had expansion of, for instance, the antibody drug conjugates. Back at that time, we didn't really have the confirmatory data on any of those drugs. Now that, of course, is very big. But the science has really advanced a lot. And so, again, that's the exciting part because it raises a whole new ideas, lots of new ideas about the approaches to treatment.
Yeah. And so speaking about latest developments, so I was reading about this Flame-3 trial and Sinaparib. So I what I understand is that it is a type of PARP inhibitor. So never heard about this before. So how is it different from other PARPs in the market today? And how has the role of PARP inhibitors, you briefly touched upon this, evolved over time? I know there were some regulations that came in the past couple of years. And so in which stage of treatment now at this current protocol are they most effective?
Yeah, so the Flames-3 trial, is basically a trial that most of the overcomers out there will be familiar with in terms of design, in that it took patients with newly diagnosed ovarian cancer, and if they had demonstrated a response to their index treatment, so from surgery on or neoadjuvant surgery on, and they finished their chemotherapy, then they were randomized 2-to-1 to sanapriv versus control, which was a placebo control. So that design, that placebo versus active treatment design was utilized in a number of trials. What was different about this trial is that it's a different PARP inhibitor for one, and two, it was done in pretty much all Asian populations. It was primarily run in China, and so we know that there's a lot of pharmacogenomic differences in patient populations, and so this was to try to evaluate the efficacy of this drug in a predominantly Asian population. So it was a trial that was a lot like Athena Mono and Nova Prima. So these were niraparib and rucaparib based trials, but it was in a drug that's very similar, probably more similar to olaparib and rucaparib than to niraparib. So there isn't a lot of biology, there isn't a lot of metabolic information known about sanaparib at the moment, so it's hard to compare them directly. But from its metabolomics that we know, it looks very similar, probably to, or similar enough to maybe olaparib, rucaparib, more so than niraparib. So I was interested to see, first of all, how did the U.S. patient population differ from the Chinese population, and actually was able to take those results from the progression-free survival in this all-comer population and kind of overlay them. And we see that there's a lot of similarities, so a lot of overlap. So, more data. It's early, so they only had, it was to give 2 years of therapy, and they only reported, I think, up to 28 months, for follow-up. So it's early. We'll see how the data will mature. But for right now, it looks to be a drug that's similar to rucaparib and olaparib, but in a population that was similar to niraparib, the niraparib study. So, I think it's good because it provides us, again, another global evaluation of these drugs and how they work in different patient populations.
And you mentioned Asian population primarily. So would it still remain with the parameters still remain to be primarily Asian, or would it?
Yeah, it's hard to know. And obviously, that's one of the reasons why the regulatory environment in the United States is pretty tight with respect to having a US-like contingency. We don't know exactly what the number of US-like patients needs to be there, but we know if there's no US-like patients, the FDA has been reluctant to grant approval for these drugs as they enter the market. So this is kind of just the opposite. So we have a predominantly Asian population, and this will apply to the Asian, patients as a therapy option. So right now in Asia, there are, I think, 3 PARP inhibitors that are available, maybe 4 now, because there was a trial last year that also read out very kind of similar type of idea. So I think there's just more options available to them. But given that the kind of the overlap of performance of this drug in the Asian population versus the performance in the predominantly U.S. European population by those curves, they look to be pretty similar. So kind of I guess it's a good news. We have a global efficacy, not really dependent on the patient population.
Okay. So in speaking of clinical trials, which are the clinical trials in progress or about to read out that you're most excited about, and why? And tell us more about these trials and how our overcomers can sign up if they wish to.
Well, they should always check with their local doctor, to see if there is an opportunity. Most of the work, like usual, most of our work is in the recurrent setting, and so that's, there are a number of trials that are in progress, and it's, I would just, have overcomers reach out to their physicians to see whether or not they have something available to them. As you know, this is always a frustrating exercise because you'll read in general what's available, and then when you go into the details of what is truly part of the eligibility criteria, it becomes quite a bit. It can be pretty frustrating because they're maybe more restrictive, and of course that's our that's our, our intent is to try to make these trials much more available to patients. But there's a number of new assets that are coming out. What I will say is that our biggest struggle right now is to gain momentum on frontline trials. So we have since we have bevacizumab, Avastin, and the PARP inhibitors, niraparib, olaparib, rucaparib, and okay, those available to us already as options. It's been hard to beat those particular strategies in the frontline setting. And but there are some trials that have been conducted that just didn't work. One was a vaccine trial to CA-125 that we had quite a bit of experience with before, and that trial unfortunately didn't provide any additional benefit to patients as opposed to just standard of care. We have a glucocorticoid receptor inhibitor that is on its way to be reading out probably the next time we get a chance to chat. Hopefully we'll have some more information on that. And this is taking a little bit of a different approach, but a lot of these trials now are focused on something that's different than it was 4 years ago, and that's how we nuance the genomic information that we have at diagnosis. So before, we would just take all comers, and then we would try to figure out, whether or not A or B was better. Then we started to go into this understanding about how PARP inhibitors work with respect to BRCA status and homologous recombination deficiency. And so now that has now annotated a whole group of patients. So half of our patients carry those characteristics. And for those patients, we have a pretty well drawn out algorithm for the use of the PARP or PARP and bevacizumab. So the other half, the HRD negative cohort of tumors, patients that carry those tumors, that's kind of been the focus. And so we have tried to do some studies in that setting, and yet we haven't really made a big advance there. We have available to us bevacizumab and in some cases, at least for now, PARP inhibitor, but the efficacy signal could be much better. So we keep trying to push that envelope there. And that's where a number of the newer trials coming, particularly as we incorporate the antibody drug conjugates, that's kind of been a focus of us. And we'll see how this glucocorticoid receptor works in that setting.
Okay. And so in terms of options available to our overcomers who have gone past their second line of therapy, let's say third or they're in the fourth lines of therapy, what is new out there that's available? And then does this third or the fourth line of therapy look different when it comes to different types of ovarian cancers?
Yeah, it's a good question because, in the past, when we've looked at recurrent disease, in a kind of global sense, we learned that the line of therapy might have some implications as to what we might expect from these particular agents. It's gotten a lot better, a lot more nuanced. Obviously, whether the prior line of therapy, so if we're talking third line, if the prior line of therapy was a platinum, some patients, especially those that carry this BRCA or HRD signature in their tumors, some of those patients are still eligible for more platinum. It just kind of depends on what it is. How long and what kind of response they had. But for most patients who have been on a platinum and have progressed on that platinum, so the tumor has progressed, not responding anymore, then we kind of go into this kind of what we call platinum resistant. And platinum resistant ovarian cancer or platinum refractory, which is not a term we use in that setting so much, really represents kind of the landscape for where a lot of drug development is happening. This is where it's always been. But we're better at understanding exactly what are the nuances in those patients. And one of the reasons for that is another advance that's happened in the last 4 years is a more comprehensive genomic sequencing and protein evaluation of these tumors. And that has led and ushered in a number of ideas. Some have not worked, but some have. Probably the greatest success story we've had is to identify on the surface of these cancer cells specific proteins that can be used as kind of a homing device, or a targeted approach that will essentially bring a chemotherapy selectively to the cancer and try to avoid the chemotherapy use and oft in the normal tissue. So that kind of selective targeting of chemotherapy, and that's been probably the biggest explosion in drug development has been these antibody drug conjugates. And they're kind of we were able in the last 4 years to show that one of them that focuses on folate receptor alpha, which is one of those surface proteins I just mentioned, with a drug called mirvetuximab, that this was able to shrink tumors in patients who had prior treatment and had become quote unquote platinum resistant, even requiring in a phase 3 requiring bevacizumab. So these are all patients that are in the phase 2 requiring patients to have that prior exposure. So pretty kind of focusing in a population that have seen a lot of what we have to offer. And we started to see that we could shrink tumors and keep them away for a while. And then we did a big phase 3 trial, which showed that confirmed not only that it could do that, but it actually led to an increase in overall survival. And that Miracell trial, was really, it was a year ago that it was presented, a little more than a year ago. And, lots of people in the audience, especially the newer investigators, probably didn't have the sense of historical impact that trial demonstrated. Because, for those of us like me, who've been around a long time in this drug development space, we hadn't really seen a drug in platinum-resistant ovarian cancer actually increase overall survival. It's a very difficult endpoint to hit in a trial where patients can have options after they go off the study drug. But this one did. And so this 30% reduction in the probability for death was unprecedented. And so although a lot of people look at it and say, well, it's not that much. In reality, it is that much because it's also something we've just not seen previously. So with that particular demonstration of the principle, the kind of proof of concept, and then obviously the efficacy of that drug really opened up the world to ovarian cancer patients to these new ADCs that, for instance, don't rely on as much expression of that protein, or can take advantage of different protein expression, or can take advantage of different chemotherapy drugs. And so what's been really neat to see now is that many of our pharmaceutical friends are working on ways to continue to nuance this platform by adding, for instance, 2 different chemotherapies on the same molecule, or using 2 different antibody approaches to attack more tumor types at the same time, or to come up with these linkers that hold the chemotherapy onto the antibody that are able to dissolve over different periods of time, so that there gives kind of like extended release opportunity. And they're becoming more selective so that we don't have any, so that we reduce the off-target side effects. Yeah. So that's been a platform. I think that's been really exciting, and that will continue to develop. So when we do the 200th episode, what we can talk about is what's happened in that field, because these antibody drug conjugates are essentially focused on a specific platform where there's an antibody. It kind of looks like a Y-shaped molecule like this. And then these 2 ends are the things that target the cancer cell. And then attached to it, like my watches, that's what delivers that's the chemotherapy delivery. But what they're learning is that if they modify the structure of this Y-shaped molecule, they can actually induce an immune response in a certain kind of way. Or they can eliminate an adverse side effect profile that could happen. Or it can be delivered in smaller molecules. So we call those nanobody and antibody conjugates. So these are or nanobody drug conjugates, NDCs. So these are newer molecules that are smaller, can get to different places. So when you think about the technology that's coming to make a hypothesis that we observed 4 years ago now into these new therapies, that's what's coming. So and of course, there's no shortage of biologically targeted mechanisms things like I think, we mentioned in the past, like WEE1, different biological pathways like the PI3 kinase pathway. We have selective PARP inhibitors, so only targeting one enzyme of the PARP family. There's many, many, many things again that are ongoing. So to answer long answer to your question, but really the question is to talk to your doctor and see, to help the doctor or the study coordinator explain to you why certain things, why certain trials are available or not available. But always ask. Every time I say this every time. So every time you're going to change therapy, you should be asking, is there a trial for me? Every single time. The biggest mistake you can do is say, I'm not sick enough to have a trial, because that's the exact opposite of what we want to do. We want to do it when you're healthy so that we can actually evaluate these treatments.
Makes sense. And you mentioned the WEE1 inhibitors, and which is a great segue to my next question. We have been hearing about this for a while, and tell us a little more about this WEE1 inhibitors and the need for developing therapies that inhibit this particular protein in ovarian cancer, and why is its role significant, and what should our overcomers know about this?
Yeah, so WEE1 is an interesting chemical. We call these cell cycle checkpoint inhibitors. So we talk about immune checkpoint inhibitors, and so those are targeting parts of the immune response that either that check the response to make sure that doesn't go too much or too little. These particular molecules, and there's many in this pathway, govern kind of the cell cycle, so cells, as they come out of their dormancy, they kind of go into a growth phase, then they kind of synthesize the DNA and then split, and then they become two cells. And so that process, that cycle, and it just repeats over and over again, that cycle is governed by many different proteins. And so if you think about it, if the cancer cells are going through that cycle much more rapidly, or more cells are going through it much more rapidly, it would be advantageous to be able to put stopping blocks in that pathway, so that these tumor cells would be differentially sensitive than the normal cells, which are slower growing. So that's kind of the general principle of even chemotherapy. But WEE1, is just one of those surveillance proteins that governs the cell cycle, and it occurs generally relatively late in the cell cycle. So the reason it was a kind of a focus or a target for us in ovarian cancer is that another cell cycle regulator is probably a protein many people have heard about, called P53. P53 is an early regulator of that same cell cycle. So when P53 is mutated, which is seen in 90+% of high-grade epithelial ovarian cancer, that first checkpoint is gone. So there's no regulation of that first, in the early part of the cell cycle, of that checkpoint. So cells then differentially go into the second part of the cell cycle with damaged DNA. And so WEE1 is another governor of that pathway. And so if we can inhibit that, take it away, then the damaged cellular structure of that DNA goes all the way through the cell cycle and provides an opportunity then for that cell to die, because it has disorganized, completely screwed up DNA. So it's kind of a two-hit thing. So if you have mutated P53, to be able to inhibit WEE1 makes a lot of sense. And WEE1 has a lot of other governing regulatory components that are pretty complex. But it's also been interesting as we've learned more about what this governance is with the cell cycles, that we learn that there are other factors that work with WEE1. And so now with respect to drug development, there are co-inhibitors coming that work on WEE1 and some of its partners that are part of that cell cycle regulatory pathway. So it made sense for us to try to focus this, and as Shannon Weston and I worked on this for many years now in ovarian and in endometrial cancer. We were focused on this because WEE1 could be a potential mechanism for resistance to PARP inhibitors. Yeah. So we felt that since PARP inhibitors also work on DNA, and that if the cells were sensitive to a PARP inhibitor and became resistant, one of those resistance mechanisms could be related to WEE1 activity. So that's why we focused on working on WEE1 inhibitors in either in combination or in patients with previous PARP exposure. And so, I think we did get a strong signal. What we didn't probably realize, and it goes back to my kind of my preamble here, which is that cells that are going through the cell cycle fast, are governed by that. Well, what other cells go through the cell cycle fast? And you can think about it, it's just as you would imagine, bone marrow cells go through the cell cycle. And so we learned that it was hard to give both a PARP inhibitor and a WEE1 inhibitor together because of the toxicity. And even some of the single agent WEE1 inhibitors have come up with some toxicity. So, just as the process, keeps repeating, we form a hypothesis, we test it, and we observe. And what we did is we formed a hypothesis, we tested, we observed efficacy and toxicity. So then we went back to the drawing board and said, okay, why is this happening? And so now we're redoing these trials with different schedules and dosing, and looking at different partners. So it's exciting. It's a new pathway for us to evaluate. I think we're at the earliest phase of this now. And there have been a few generations of these WEE1 inhibitors. We're working with one called azenosertib, which is going through at least three different trials now to see how it can hopefully help our patients.
Wonderful. So you mentioned endometrial cancer, and this is again a great segue to my next question. We are hearing a lot about endometrial cancers these days. So,
Thank God.
So can you tell us a little more about this particular type of cancer, and are there any overlaps between endometrial and ovarian cancer? Could a patient present with both ovarian and endometrial cancers? And if so, what is the typical treatment protocol for that?
Yes. So there.
Okay.
I have one question with 18 parts. No,
that's usually how I
roll.
know,
exactly. So, no, I love it. I just mess with you. It's morning. What can I say? It's coffee. So for those of us who've been in the business a while, this has been probably the biggest excitement for us to see that companies now are interested in doing work in this space. When I was in fellowship, there were really only two options for adjuvant treatment, for recurrence treatment in endometrial cancer, and that was old chemo or hormones. And we didn't really have a lot of success with either of them. Just to kind of put this in perspective, we had a readout of a trial that took like 10 years to get into publication. That was just looking at a 2-drug versus 3-drug combination of just old chemo. And it was so hard. I remember having so many of these conversations to talk to companies to say, listen, endometrial cancer, is a important disease that needs investment so that we can see what's going on with these tumors. Fortunately, in 2013, we started to see the TCGA readout in a number of different tumor types. Ovarian endometrial got its own, even carcinosarcoma got its own evaluation. And they said, oh, wait a minute, there's a lot of genetic aberrations here. Maybe some of these are targetable. And some of those could be targetable with drugs that they're already using in many other diseases, including breast cancer. And so then they said, well, wait a minute, there's a lot of endometrial cancer around there. Like, yeah, for sure there is. It's like so much more prevalent than ovarian cancer. And they're like, oh, well, maybe we should start paying attention to this. And so, it was exciting to see that a lot of the development that happened in breast cancer was starting to then trickle into the endometrial cancer space. And this was largely because endometrial cancer, we now see it as at least 4 different subtypes. We used to just look at it in kind of these 2 old categories that we call type 1 and type 2. And the type 1s were the patients who had kind of early menopause. They may have been exposed to, they may have developed their endometrial cancer with respect to hormonal replacement therapy, which is a whole story in the 70s and 80s. Or these patients that were, elderly, had a lot of comorbidities, or African American, and they had a kind of a type 2 high grade, kind of different type of tumor. They had different kind of natural histories. we've now come in and we say, listen, if you take all these endometrial cancers, you can see there's at least 4 different genomic subtypes. But even in one of the kind of and those would be these, I'll just say them real quick. There's a POL-E, there's a MSI high, there is this copy number low, and then this no specific mutational profile. These 4 kind of categories that describe endometrial cancer patient tumors. And so we said, hey, wait a minute, within each one of these groups, there's actually even more nuances. And so today we now have a much broader appreciation of the heterogeneity of endometrial cancer. But the good news is that there are strong molecular drivers. So kind of unlike ovarian cancer, where we have, this p53 mutation, which is most common, but then there's all these other kind of drivers that are very heterogeneous. So, the primary and the metastatic sites might have completely different biologies. And that's why it's so difficult. It's not a clonal expansion. But we see in a lot of endometrial cancer that we do have this kind of clonal expansion, and that's allowed us to start investigating a lot of different drugs. So I think I messed up the TCGA. So let me just say it again because I want to make sure we make this point. So there's the POL-E, then there's the MSI high, which is or DMMR, which this is why I want to say this. And then you've got your copy number high and copy number low. So the reason these 4 categories are important is that the POL-E, we realize, have a hypermutable type of tumors. The MSI high are high mutable tumors, but they get there because of a specific defect that drives the tumor, and that's microsatellite instability. And then this copy number high, copy number low kind of splits apart the old 2 categories that we used to talk about as type 1 and type 2. So the copy number high are those high risk elderly patients that are driven by p53 alteration. And then the copy number low is what we used to call that type 1 kind of group, and it's driven by all of these hormonal pathways and other targeted pathways. So they have really distinct biologies. But then within each one of those, so for instance, if we take the MSI high or the mismatch repair protein deficient population, within that subgroup, we can then segment even further whether or not they have these other factors. And so this again, and each one of these categories is like that. So I think in the future, what we'll have is maybe 8 or 10 categories of endometrial cancer that are driven by these specific markers. So with this realization, as I mentioned, this came out in 2013, we started to see a lot of adoption of new therapies, and probably the biggest, most groundbreaking change was the identification of that MSI high population, what we call, or the mismatch repair. And so these microsatellites that are present in cancers are responsible. If there is alteration in the proteins that govern these particular microsatellites become very immunogenic. And so these MSI high or mismatch repair deficient tumors elicited a very strong immune response. And that's how we were able to take advantage of that. So this is something we don't see in endometrial cancer. Don't see in ovarian cancer. But in endometrial cancer, we have, for the most part, in the endometrial cancer, these MSI are associated with high tumor mutational burden, and they have this innate immune response. And so that's where the immune checkpoint inhibitors were then brought in, because they were able to block that resistance mechanism that the tumors had, and we started to see these amazing results. So just like we said, we saw with mirvetuximab with an OS advantage, we saw night and day differences by the use of these immune checkpoint inhibitors with chemotherapy and then in maintenance. The effect, to put it in perspective, is that the effect we saw in those adjuvant trials or those recurrence trials is the same in magnitude as we saw with PARP inhibitors in the BRCA tumors. It's the same degree of efficacy, which is a 70% reduction in the probability for progression. So, and I think what we've done is we've actually, just like in ovarian cancer that we've seen in the molecular categories, I think we've actually changed the number of patients actually cured. which is something we don't talk about.
Yes. You mentioned, I'm going to go back and ask a question on, patients presenting with both endometrial and ovarian, and you went
Yeah.
to the P53 mutation. So
Yeah.
my curious question is, if someone were to harbor that particular mutation, then uh, could that person be at risk for developing both ovarian as well as endometrial?
Yeah, so it's so in general, the changes that we see with P53 are what we call somatic or tumor based. So there is a condition Li-Fraumeni, which is an inherited mutation risk of P53. This is a different situation than that. So each one of these tumors, even though they may carry a P53 mutation, it doesn't necessarily mean it's going to define ovarian or endometrial cancer. There are scenarios where a particular mutation can put you at risk for both those MSI high, for instance, like Lynch syndrome can be, which can make you at high risk for colon cancer, could make you just as high risk for endometrial cancer, and some of those patients actually have ovarian cancer too, or as a phenotype of that molecular alteration. So, but what we see more frequently is the co-occurrence of those two tumors. So we call those synchronous primaries. And I think maybe, oh gosh, more than 10 years ago, we were looking at ways that we could try to distinguish between what looked to be the same tumor type, but in two different organs. So we would maybe do a surgical procedure. We'd look inside the uterus, we'd see an endometrioid tumor, and then we'd look in the ovary and see an endometrioid tumor. And the question was, are these two different primaries?
Yeah.
So they both have two tumors, or are they related? Is the ovary a metastasis from the uterus, or is the uterus a metastasis from the ovary? And so in general, I think that kind of the uterus goes to the ovary can happen relatively common. The ovary going to the uterus is not, it's usually done by extension, so it's not usually on the inside of the uterus. But Pam Solomon and I, when years ago, we decided to kind of look at this from a genomic standpoint. And what we did is we looked at the mutational profile of the uterus and the ovaries independently and saw whether or not they carried the same profile or not. And we were alarmed to find out that in some cases, indeed, it is that process of a stepwise mutation. It starts in the uterus, goes to the ovary, and then from the ovary to the outside of the ovary. And they gain mutations in each one of these steps. And in other cases, they're completely separate genomically. They are just happen to come up at the same time. And so then we said, okay, well, maybe that makes a difference from a therapeutic standpoint.
Right.
And that's where, excuse me, and that's where it kind of broke down. The pathologist would make an estimation on the basis of their the way the tumors looked under the microscope, and they would say, well, I believe based on the features of this tumor, this is a metastatic event. And we said, no, this is based on the genomic information. It's actually a metastatic event. But when we looked at the outcomes of the patient, it didn't matter. In fact, it was better for the pathologist to opine if it was one way or the other than us using the genetic information. So there's more work that needs to be done here to tease out exactly what's happening there. But we think that when these tumors occur in both organs at the same time, what we do is we look at the highest risk of the two situations and treat on the basis of that. So if we don't have a clear signal, if it's ovary or in vitro, we look at the one that has the highest risk for recurrence. Frequently, what we see with these synchronous primaries is that the uterus is a very low risk situation. The ovary represents the same high risk, even though it may be early stage. And so we end up treating on the basis of that.
Okay, thank you. Great answer. So I wanted to talk to you about the second look surgery, right? It seems like
Yeah.
beginning to gain a little traction again. So can you please tell us your thoughts on second look surgery and what should our overcomers know about the latest word on it, and what questions should they be asking their doctors and healthcare teams I guess it's the desktop 3 trial.
Oh, okay. Yeah. So a little different. So there's yeah, so let me maybe clarify some of the nomenclature. So second look was a procedure that was that was done actually at the National Cancer Institute many years ago
Yeah.
in an attempt to try to understand whether or not cancer was gone. At that time, our approach to ovarian cancer was to basically just treat until either patient couldn't take it anymore or the tumor grew through the treatment. So there was no like 6 cycles and then, maintenance and let's see what happens. And so the second look was really in place of accurate radiology. So as radiology got much better, the second look seemed to start to fall out of favor. And back in the early 2000s, we did a trial called GOG 158, which looked at Taxol carbo versus Taxol cis. Back then, that was the question. In the 90s, that was the question. And so we found in this trial, which was a non-inferiority trial, that that Taxol carbo was at least non-inferior to paclitaxel cis, which was good because it made it an outpatient regimen. But part of that trial had the option to do a second look or not. And, and so in this very large study, at the completion of chemotherapy, patients underwent a second look. And what we found is very much the same kinds of things that we had learned before, was that many times when the CAT scan is negative, they can find disease that's still present, which then kind of like supported this idea of using a maintenance strategy. But when we looked at the patients who had a second look versus those that did not have a second look, there was no difference in outcome. So the second look as a therapeutic intervention wasn't really doing anything for us. So that's what's happening a little bit more with second look is that there are opportunities now to look at if they do find residual disease at the time of completion of chemotherapy, maybe there's something we can go after and target. But it can also be looked at in the other way, and that's what's kind of going on right now, which is that they're also looking at circulating DNA in patients who have finished their chemotherapy and determining whether or not, if a second look is negative and the circulating DNA is negative, then maybe patients don't benefit from any kind of maintenance. So this is kind of like a reduction in treatment, so we can avoid treatment in patients that have very low risk for recurrence. So it is making there are some immunotherapy protocols ongoing right now on the basis of small volume persistent disease that's been present after chemotherapy. So that's second look. Now, the secondary cytoreduction is a different procedure. This is a situation that in modern terms is related to the fact that patients will have their initial surgery and chemotherapy, and then they'll be in a period of observation. And if the tumor comes back after a certain period of time, then they're taken back to the OR and then undergo another surgery. So that's called a secondary cytoreduction. So different from second look, because second look is done at the completion of chemo, secondary cytoreduction done after recurrence. And it's actually fairly controversial. So we've done now, there's been a grand total of 5 trials that have tried to look at this question. 2 of those trials were actually closed for futility. It was very hard to complete the trials to get them enrolled. 3 trials have reported. The first one that reported was Desktop 3, which is you just mentioned. The second one that reported a year later was GOG 213, which was the trial I was responsible for. And then the third one that appeared about 2 years later was called SOC1. And that was done by predominantly in the Chinese population. And so these 3 trials they're controversial because the 3 trials in general show that in their primary endpoint, they come to different conclusions. So all 3 of these trials had an overall survival kind of endpoint. In my trial and in GOG in Desktop 3, our primary endpoint was overall survival. And in my trial, we did not see that surgery actually increased overall survival. In Desktop 3, they suggested that patients who had surgery did have an improvement in overall survival. And in SOC1, which hasn't really reported out yet completely, it appears that that's probably also not going to show a difference in overall survival. So 2 out of the 3 trials missed their primary endpoint. With respect to the other endpoints, like progression-free survival, which is the time to the first recurrence, 2 of the trials actually showed an improvement in progression-free survival if they had surgery, which kind of makes sense. Like if you have a tumor, you take it out and you give chemo, there's a good chance that it'll take longer for the tumor to grow back. In my trial, 213, or the trial that we did with the GOG, we did not really see a big effect on progression-free survival. So we say, well, why are these trials so different? Well, one of the things that happened during the course of these trials, they took a very long time to enroll. Like my trial took 10 years to do. Almost the same thing with the desktop series, is that the treatment landscape changed.
Mm.
So all of what we talked about in the first, half hour of our conversation came about during these trials being done.
Yeah.
So when my trial started, I only had 3 kids. So you can tell you how long it is. I got 6 kids now and 8 grandkids. So, so there's been quite a bit of time. In that time period, bevacizumab demonstrated its efficacy in the recurrent setting, and PARP inhibitors demonstrated their efficacy in a recurrent setting. So in the US population, the number of patients who received something in addition to chemotherapy after surgery was 4 times higher than was seen in the other trials. So when we look at a trial like that, we have to say, okay, were these patients, did these patients have the same opportunity to participate in these newer therapies that came during the time of the study? So it wasn't purely a surgical question. And this is, and I've had to do, since my trial is so much different than the others, we've had to have like 100 debates about this. But one of the things that's really different about these trials is that we're not looking at surgery alone here. We're looking at surgery and something else.
Yeah.
And in all these trials, the surgery is very much the same. In fact, and I do this all the time, if you take the surgical arms of all 3 trials and you overlay them, they're almost exactly the same. So the surgical arm with controlled treatment across the world, pretty much the same outcome. What's different is that in GOG 213, the patients who got the better adjuvant treatment, the better chemo, those patients did better than expected. And so I think that's the underlying mechanism between those 3 trials and why it's so confusing. So yes, I think many of us feel that as the frontline therapy has gotten much better, the amount of patients that end up with recurrent disease that's really platinum sensitive, and maybe because we do so much surveillance, has very small volume disease, that those patients actually might be really good candidates for surgery, even though my trial suggested that it wasn't going to be that big of much of a benefit. So it's still an open question, but I think the trials did help us to understand that if you take a patient to surgery and you can't get the tumor out completely, those patients in all trials don't do as well.
Yeah.
And they don't do as well as if they didn't even have surgery. Okay, so that's the key message. If you have recurrent disease and they don't think they can get all the tumor out, it's better not to operate at all.
That makes sense. Thank you so much. So you talked about progression-free survival and overall survival. That was your perfect segues into my next question. So my question was that when the progression-free survival goals are met, but the overall survival is not, then what does it really mean for our overcomers who are in the trials, and what lessons do you learn from clinical trials that do not meet endpoints?
Yeah, again, lots of questions in there. But so one of the things that a patient, and I just had this conversation with a patient recently to talk about this idea. There's a very big difference between what we call population-based data and patient-based data.
Mm-hmm.
Now, patients obviously make up a population, but the data that we talk about with progression-free survival and overall survival refer to the impact of treatment in a population of patients.
Yeah.
So if you think about a bowl of like jelly beans, you have all different flavors in that bowl of jelly beans. And if you look at, the amount of jelly beans that were eaten out of one bowl versus the other bowl, and there's a difference between those two, and that might be, for instance, progression-free survival. So, but at the patient level, you could be a benefactor in either one of those two bowls. You just don't know. So it's a very different thing to talk about the efficacy in a population from a clinical trial and the efficacy in an individual patient. And so that's the kind of the first big kind of realization that patients need to understand. When we say that let's say we'll use mirvetuximab. So in that particular trial, we saw a reduction in the probability of progression by 30%.
Yeah.
Okay, what that means to the patient. So what it means in the population is that if you look across the whole population, that the risk for any patient along those treatment arms was improved by this 30% if they were on the experimental trial, the experimental drug. At the patient level, the benefit of that risk starts on day one. So a patient who starts the new therapy versus a patient who doesn't start the new therapy on day one, they have the same, obviously, the risk that day.
Yeah.
But as time goes on, the risk, even though you may not observe it at the patient level, the risk is actually reduced by 30%. And when there's enough time, what you find is that, let's say at 2 years, you might find that, yes, 30%, that this patient has a 30% better chance of being without progression at that point in time. Even though, so the population data and the individual patient data are experienced in different ways.
Mhm.
And so when a patient comes and says, what's the best for me? Well, what I will do is I'll say, well, in the population, I don't know which side you're going to be in, but in the population-based data, there's a 30% reduction in this probability for progression. And if you're on this therapy, that's what you're assuming. I don't know if it's going to work or not, but that's the benefit that we can give to you in that way. Now, when patients have a progression event, so if this is, let's say this is in, and let's say this is when we did our first conversation topic that we did in 2020, you had been on a therapy and you had a progression event. So in 2020, what did you have available to you to get additional therapies? Well, we didn't have anything else really outside of what, we had some of the PARP inhibitors that were kind of cooking, but really didn't have anything else. So what happened in terms of after progression was unknown.
Yeah.
Now, if let's say today you had that progression event, what would you have available to you today? Well, now we have a whole bunch of new drugs that you could go on or that potentially could be approved here real soon that you would have available to you. So progression-free survival and overall survival are disconnected by this time period where there can be new therapies that can influence the outcomes. So what we usually say is that if the time from progression to the time of death is compressed, then the ability of the progression-free survival to predict the overall survival is pretty high. In fact, if you think about it, the way we do our trials with progression-free and overall survival, if everybody who went on the study died the day they progressed, the two curves would be basically the same, right? Because there's no time in between.
Yeah.
But as that time grows, the ability for the first event to predict the second event goes down logarithmically.
Makes sense.
And so it's very difficult. That's why I said the MIRSOL trial is so groundbreaking, because it's so hard to demonstrate that a benefit in time to progression will equal a benefit to time to overall survival. So at the population-based level, because of all the heterogeneity of options that patients can get after they progress, you can see why that could get that efficacy could get kind of diluted. At the patient level, the longer you live, because you're now available to get the next best thing.
Absolutely.
Okay, so that's why it's really important to understand that when we talk in generalities, like we've been today, we talk about population-based data, but at the patient level, it has a lot of difference.
So between the progression-free and the overall survival, which one is the more important metric in your opinion?
So it's for me at the patient level, it's the first next thing.
Okay.
That's why I really focus on, from a patient level perspective, you want to be around as long as possible. So what you want to do is you want to have the longest time to the next recurrence if it's going to
Yes.
happen.
Mhm.
Hopefully it'll never happen, but if it does happen, you want the longest time there, and then you want to get on something else that produces the next longest thing, right? So at the patient level, it's always extending what you're on. Stay on it as long as you can, and hopefully over time, as new therapies become available, those will be available to you. In a clinical trial where everybody's kind of enrolled in a short period of time, and then we're following them for a long period of time, I personally still believe that progression-free survival is more important than overall survival in terms of a metric of efficacy for that same reason. But it's really valuable in many regulatory environments to demonstrate that the overall survival is also improved. We just have to realize the regulatory agencies have taken, kind of different stance on this around the world. But in my opinion, in a population-based study, it's probably less important at the individual level as an endpoint.
Thank you. So, as we talk about the progression-free and the overall survival, we know that, patients and overcomers differ in terms of, for some people, cancer comes back within a year. In my mom's case, it came back within 2 months. In certain situations, it's 10 years and 15, 20 years, and they're still, the cancer has not returned, which is what we all want, right? So
Mm-hmm.
in terms of the genomic and the immune characteristics of tumors of these particular women, that have been long-term survivors. What kind of studies have been conducted, and that have these women been followed to learn more about their particular, you
Yeah.
know, progression, which everyone else wants, and what
Mhm.
lessons can we learn from such overcomers that we could potentially apply to everyone else?
Yeah. So this is a great question. I actually have a poster and a manuscript that were in place to talk about this. So Anil and I and Keith Baggerly, years ago, well, not that many years ago, but a few years ago, I wanted to tackle this question because what we wanted to say is, what's the definition of cure? So I remember I talked about this before, that I think we're increasing the cure rates. And we don't talk about that. It's kind of the C word we don't actually ever talk about specifically with patients. So we've done a number of trials to kind of evaluate, how patients and physicians actually consider that term, and when do they say? Because remember, cure is when do you know you're cured? Well, kind of cure is the absence of progression, just as you just said, right? So now, and this is a difference also between what we call cure and what we call overall survival. Now, obviously, a patient who never recurs is going to have better overall survival than a patient that does. But that's the cure is the absence of progression. So patients that are newly diagnosed have surgery, chemotherapy, and then never have a recurrence. Those are the cures, right? So, but when? Is it 2 years? Is it 3 years? Is it 5 years? Is it 7 years? Is it 20 years? What is it? And how do you know? So Neil and I and Keith started to tackle this, and this is the brilliance of Keith Baggerly, statistician at MD Anderson back in the day. And what we decided to do was to take a look at what the population risk is for non-cancer. And so we looked at an age-adjusted risk, essentially analysis for death rates due to cancer versus non-cancer. And we mapped it out across the US population. And as you would expect, a patient who has the diagnosis of cancer, ovarian cancer in this case, we looked across 30 different tumors. But if you look at ovarian cancer and you look at time, patients with ovarian cancer have a much higher risk of death than patients in the general population who essentially are, have carry just no specific medical pathology, medical history. But as time goes on, those curves which start this far apart start to come together, because the longer you're alive, the more likely it is that you would have an event that's due to a non-cancer.
Yeah.
Okay. So where do you think it ended up? So our hypothesis was that as when you got to a period of time where we statistically couldn't tell whether or not you were more likely to die of cancer versus non-cancer, that we thought that was a good definition to say that you're probably cured. So when do you think that was in ovarian cancer?
10 years?
It's very close. It was 9 years. 9 years, if so 9 years of non-progression, the risk of having a death event due to a non-cancer was the same as due to ovarian cancer. Okay. So, and it's different for every tumor type. So what that gave us is at least a benchmark about how, against which I could say, well, listen, if you haven't had any recurrence for 9 years, you're unlikely to have a recurrence from this disease. And if anything does show up after this point, it's probably something new.
Yeah.
A different new tumor. So that was one thing. So the probability of being 9 years disease-free, progression-free, is also related to a lot of the genomic factors that we talked about in the beginning. The patients that carry a BRCA mutation in the tumor who get a PARP inhibitor are statistically more likely to get out to 9 years without recurrence than a patient who doesn't carry those characteristics in their tumors. And so that's really the clearest example. We don't have many other predictors of that kind of factor because in general, ovarian cancer doesn't have those driving mutations that we could turn off as a single event. But in other tumor types, that's where they're seeing it as well. So yeah, lots of work being done on long-term responders, looking at genomic information or genomic alterations that occur during the course of therapy. So it's possible to be out at 9 years, but with disease. And we do see that. But so patients are living longer with their disease. That's actually happening in real time right now. But those cures, still looking for what that silver bullet is to a larger population of patients.
Wonderful. And I also think that, what you just said is so hopeful. And we do need to talk about the word cure a little more and not be so cautious about it. Because,
exactly.
if after the 9 years just what you just mentioned, that your probability of, cancer versus non-cancer, eventuality is pretty much the same, then we should be using the word cure at that point.
That's what I think.
It causes a mind shift. It causes a huge shift in your head and your, the way you look at cancer. So I'm all for it. I'll vote for it. But so you spoke about immunotherapy, and I know we are over the time, but it is also a special episode. So just briefly, what do you think we should be in terms of immunotherapy? Should we still remain hopeful when it comes to immunotherapy in ovarian cancer?
Yeah, I think, I think our initial attempt at looking at immunotherapy was just adopting what we learned from melanoma and lung cancer and other tumor types that have this innate kind of what we call clonal expansion, meaning that all the tumors kind of carry the same characteristics. We learned that in those initial trials that we did, and we did a lot of big ones in frontline and in recurrence, and all of them basically failed. So, which was a real big disappointment. And we noticed that as single agents, when we use these drugs in patients who have recurrent disease, the response rates are no better than, basically ineffective chemotherapy. So there's much more to the story. One of the things that we found is that ovarian cancer, that each of the different locations of the tumor can have even within the same tumor, can have a different kind of immune signature. And so using just one immune checkpoint inhibitor, for instance, is probably not enough. And so that said, well, then maybe we need to do combinations. And those trials have started. And many of them show more toxicity with not a lot more efficacy. So I think it's a much more challenging disease than some of the other tumors that we've seen great efficacy, such as the endometrial cancer and cervical cancer patients that have a reason for their immunogenicity, like for instance in cervical cancer is HPV infection, and endometrial cancer, those deficient MMR mismatch repair states that cause an immune signature. We don't have that as a global phenomenon in ovarian cancer. So it's going to be much more nuanced in ovarian cancer, subsets that will identify that potentially might be candidates. As I mentioned, about 8% of our ovarian cancer patients also carry this kind of this mismatch repair signature. So we're looking for it now. We're looking for these small cohorts within the bigger group of patients that might actually have a more robust response to it. So, and then there's just different ways to engineer the immune system to make it more to attack in a broader way. And so these types of bispecific T cell engagers, bispecific B cell engagers, CAR T, all these types of strategies we've used in liquid tumors, now kind of getting into the solid tumor space. We're just at the very beginning of it. But one of the things we learned, at least with immunotherapy and ovarian cancer, is that we can't cut and paste.
Yeah.
So we can't cut out of melanoma and paste it into ovarian cancer. It's going to be much more nuanced than that.
Thank you. So we talked about cure, and so I'm going to ask you this question. We will eventually get to the 200th episode, and do you think by then there would be a cure for ovarian cancer or not?
Well, I think we're already there. As I said, I think we've already got, we have 7-year data now with from SOLO-1 in those BRCA tumors, and we're getting there. The event rates are going so slow, and I think we're going to see a 2.5-fold increase in cure in patients whose tumors carry that. But I think for the common type, the wild type patients, I'm hopeful that we'll be able to probably first string along a series of therapies that keep patients alive for that long, even if they're with disease. Identifying at the very beginning the patients that will never have a recurrence, or patients who do have a recurrence but then are cured.
Yeah.
That I think will probably take a little more time, but I think there's a lot of new tools in our belt, not only from the standpoint of available drugs, but kind of what's coming. How do we use mRNA? How do we use short interfering RNA technologies? There's a whole bunch of new stuff that is, that has the potential to induce these long-term, situations where the immune system or the tumor cells themselves are regulating their recurrence. So I think I don't know if it'll happen by the 200th episode, but I do think that we're going to have more options.
And I do think that, by the time we reach the 200th episode, AI would have been much more integrated into the medical practice, and with AI exponentially, so the growth is going to be exponential in the next whatever number of years we get to the 200th episode. So I feel like it's not impossible.
Yeah, I think that the algorithms to help us sequence agents based on variables that we're collecting will probably be in place. It'll need to be refined. But the one thing that's beautiful about AI is that it's able to do kind of multi-dimensional incorporation of variables. Right now, we're limited because of patient sample size to be able to look at 50 different potential influencers at one time. So we don't have the ability to see that in a 50-dimensional space. But with AI, we may be able to come up with some much more precise guidance as to what is the best therapy based on what I hope will happen is that we'll have functional biomarkers. So something that actually describes what's happening in the tumor right now, as opposed to looking at the tissue that was taken out at primary surgery. So I think that will evolve. We didn't really talk much about that, but those type of functional assays and biomarkers, as time goes on, those will occur.
Wonderful. So, Dr. Coleman, what do you think is special about Connect Over Coffee, and what has been your favorite moment with Overcome? It's been many long years, but yeah.
It's that I get to spend time with you. That's the best part. No, of course, the biggest deficit we see is the lack of communication and understanding, and these opportunities to have live conversation, to kind of go through. I think not only does it provide information, but one of the things that it does do, I think, is provides hope. And you know how I feel about this. The opportunity to reduce stress in the body has a profound effect on tumor biology. And so I believe, and strong faith about this, that this kind of information, opportunity to spread information, to understand what's coming, keeps people hopeful that even though they have the day-to-day grind that they have to go through, that they know there is a legion of people that are trying to make their lives better. And we're doing this through clinical trials and, standardized care and, development of new clinicians and researchers to try to change the environment. So having these conversations is super important to keep people informed, but also to keep them hopeful that we continue to chip away at this problem and to hopefully make their lives better.
Thank you. And in closing, as I always ask you, and as a special 100th episode question to sign off, what message of overcoming on our special 100th episode would you like to share with our overcomers?
Yeah, I always say this because I'm so passionate about it, but research cures cancer.
Yes.
That's my I didn't make that motto up, but I've used it in my talks since 1997. Research cures cancer. That's the only way to do it. So if you have the opportunity to participate, please consider it. If you have participated, thank you for helping us understand these questions. Don't be afraid to ask, speak up, and but that's the message. And so I have to applaud you, Runcie, from all of what you've done, and with this process, what you're doing locally, what you're doing nationally. This is how it gets done. So I applaud you and all of that you've done. It's been so great to work with you all these years, and I'm looking forward to the future.
Yeah, we are growing all together, and we are also learning together. And
Yeah.
It's been an incredible journey. So thank you so much, Dr. Coleman. We are so grateful to you for all that you have done and supported us through the years with your faith in us and, in our vision to help our overcomers worldwide. So thank you very much for joining us today.
Absolutely. Thank you so much.
We are making progress and that's improved substantially over the last 20 plus years. That doesn't mean we're done. That it doesn't mean that we're curing more patients, and that's the kind of work I think that needs to be done. But we are making progress, though.
We have a lot of reasons to have a lot of hope, and you deserve that. And so if you're not getting that where you are, you need to find a place where you can feel that, because that definitely has a huge impact on your overall outcomes. We need our mindset positive as we can. And so I think there's a lot of reasons to be positive for patients with ovarian cancer, and we're going to continue to push.
If there was some way to really get the word out that when you get diagnosed, don't panic. Don't just go to somebody and have some incomplete operation or start on chemotherapy without a full assessment, and just go to people who have experience and a passion to do this. I'm not exactly sure how that actually gets done, but I know you all have a better chance of accomplishing that than I do. I'm just sitting in my office in New York. You guys have a much farther reach than I do.
There is hope. I think, let me just put it simply. There is hope, because we know more than we ever knew before. I mean, who would have thought 15, 20 years ago that within a few days we can sequence the entire genome of a cancer to understand potential targets, potential drugs that we can use. So that has become routine now, where we can do molecular testing and use that to identify clinical trials or to triage a patient to appropriate forms of therapy. Who would have thought about PARP inhibitors 15, 20 years ago, maintenance therapy? So we're seeing prolongation of survival, good quality of life. We are seeing all of those things, but the work is not done. There's a lot more to be done. And that's why organizations such as Overcome is so critical to help us to get the message out that there's hope. We now can do a lot of things that we never could have done before. We have a deeper understanding We talked about some of the different subsets of ovarian cancers. We now know that they're not the same. Therefore, the way we think about treatment is different. We have advances in molecular engineering, advances in drug discovery and development. We talked about the use of oncolytic viruses, the drug factory, different ways of manipulating the immune system. All of those things, I think, are going to come together to help ovarian cancer patients. So if you're listening, there is hope. And I cannot wait to see that day where this becomes history.
You know, I walk into clinic every day and I meet with these women who are struggling and suffering, and yet they maintain their beauty and their grace, and their care for their families. And you know, so many of them are all about what happens to other people, not what's happening to them. They're worried about what's happening to their families, their children. Honestly, some of them come in and they're worried about what's happening to me. And I'm just like, what? I mean, you have cancer. Don't be worried about me. Right? But there's this beautiful grace and acceptance and love of life and of the people around them that emanates from them that we all should take an example from.
Well, first of all, I'm sorry that you or somebody that you know is going through this. It's a tough battle, but it's a winnable battle, I think. And even if it, doesn't mean, necessarily cure for everybody, it could be continue to live for as long as we have, right? One certainty in life is that there eventually will become death. So I think it's important in either case, whether you're able to 100% overcome, or if you're just overcoming and living the way you want to live. So I think, to take a moment, there will be hard times, there will be tough times, but appreciate what I call the collateral beauty, which is every good moment is going to mean so much more to you, because you're going to appreciate, because you've been through the bad and you've been through the dark. And so, life's a gift, and, it's a present. So live it. That's my recommendation.
Wonderful. Thank you so much, Gabby. And Dr. Ramirez, how would you like to share your message?
Yes, and I would only add that recognizing that this is an incredibly difficult time and a difficult disease, that never lose hope. Continue fighting, continue living, continue being inspiring, and continue sharing your story with others.
Many physicians and investigators who are now interested in rare cancers because they see the progress that's already been made. The pharma companies, I think, have an increased interest now in developing new drugs. The National Cancer Institute is reinvigorated, I think, and is more commonly funding some of the studies for rare cancers. So that's one point. The second point I would make is that advocacy organizations like Overcome are so important. They've been really critical in terms of awareness, education, fundraising.
Yes.
For sure. And Overcome has done a great job. And they've partnered with, in many instances, they've partnered with physicians and investigators, as Overcome has in many ways. What I would like to see moving forward, though, is I would like to see advocacy groups get more involved in advocacy or lobbying of FDA, National Cancer Institute, pharmaceutical companies, to be much stronger in the advocacy to make them aware that that the treatments are limited. We need new treatments. We need new studies. We need to learn a lot more. We've just scratched the surface with a lot of these rare ovarian cancers. And I think there is increased advocacy now, and I think it will only grow over the next decade or so. But that, I think, is something we really, as physicians, want to partner with the groups and want to see much greater advocacy.
First, to the patients that live each day to its fullest. Smile when you see the sunrise. Hug those around you. That hope and joy really do help you live your best life and can actually have impact on your immune cells, and that really will help you in your journey. For family members, being there by your loved one's side is so important. You too are part of their important parts of their care team, but you need to take care of yourself as well. Caring for the caregiver is very important so that you can be back and having those times for yourself. If you've had a family history, if you have a family history, find out as much information as you can. Embrace those memories and drive forward your voice. Knowledge is power, and we are getting closer and closer to answers as the number of investigators in this space, the collaborations are all ongoing. So I think there's great hope on the horizon, and hopefully we'll all meet again at some point in the near future.
Neat research that's happening that I can't help but be very optimistic. And I want your audience to know that we're all working super hard. None of us are happy with the current state of affairs for care of ovarian cancer, and that we are working tirelessly to make the future brighter and to just hang in there. The future, already in the last 5 years, there have been multiple new approvals for ovarian and other gynecologic cancers. And, you know, I also like to just briefly mention the example of endometrial cancer. Not long ago, endometrial cancer, like ovarian cancer, was a disease where immune checkpoint inhibitors had a 10 or 14% response rate. But then, you know, newer information, subtype classification, addition of other drugs in combination has now increased that benefit to about 40% of ovarian or endometrial cancer patients derive benefit from some sort of immunotherapy. And so that's a great example that's just happened in the last 5 or 6 years of a cancer that seemingly immunotherapy didn't work, to going to a cancer where immunotherapy is becoming early and earlier line of treatment. So that should hopefully, you know, we should be able to emulate that model in ovarian cancer.
Mine's been forgotten for a long time. Historically, and we kind of got the leftovers from breast, and then we tried them in gyne. But I think there's been a real shift in the past 7 years, 8 years, where big pharmaceutical companies are really investing a lot of preclinical and clinical work into things that work in the front line, you know, not just things in the second and third and fourth lines, really novel drugs that weren't in breast first or in colon first, like things just for us. And true in endometrial as well, and cervical cancer, like we're developing in those spaces drugs just for us, finally. So I'm happy about that shift, and I think it should hopefully give you hope that we're going to keep coming out with options. I saw a 42-year-old yesterday who does not have BRCA. I don't understand why she has high-grade serous ovarian cancer. I cannot explain it. She should not have this. It shouldn't be platinum resistant, but it is. And she's kind of decimated about it. But I gave her like I don't want to overwhelm you, but here's the 15 options that I have for you, and let's pick the top 3. And then you pick, and we'll roll with it. And if it doesn't work, we'll go to this. There's lots of work being done, lots of options. If someone's telling you you don't have options, you need to ask for a second opinion. And don't be afraid to ask for a second opinion. If someone's insulted by that, I mean, that's just not someone you should be seeing, honestly. So don't be afraid to reach out to other places and, you know, find out what else is available for you. Because sometimes there may be something amazing around the corner that you just don't know about.
Yeah, I mean, I think I've shared a number of different messages of hope already around, you know, the improvement of how long women live for with this cancer, the improved genetic understandings of ovarian cancer, really a breakthrough with mirvetuximab being accelerated approval in November of 2022. The first antibody drug conjugate approved, but also the first new drug approved since 2014. So that to me, I think is a very important next step. And then, you know, just doing the legwork, you know, hitting your oncologist with questions and making sure that you write things down before seeing him or her, and understanding your cancer as best as you possibly can.
So I would just want to say one more thing, that I really believe that getting a optimal staging study in the very beginning is very important. And if you do have cancer, go to a tertiary care center where they only operate on cancer patients, so that you can get optimal surgical debulking where there's no residual disease left behind, and that would improve their survival. That's really important, I think, and that's the algorithm we should be following. And then I believe that every patient should get optimized care, a great imaging study, so that their disease can be found.
So someday, and I hope someday soon, with ovarian cancer, as we get better and better at treating it, the biomarkers will mean more and more, so that detecting it early means that you just don't have more time to try more tests, but you stand a much better chance of being cured for recurrent disease. We're not there yet, but that's where the biomarkers will be even more useful than they are now. And I think we still have a ways to go with targeted therapies. Immunotherapy still is. I just listened to a lecture by Deb Armstrong this morning about the status of immunotherapy for ovarian cancer. And I think that the checkpoint, she was actually talking about one patient who has gone now for 3 years with disease under really excellent control. She's required some additional radiotherapy recently, but had just a dramatic response to checkpoint inhibitors. Overall, though, it's probably about an 8 to 10% response rate, and for checkpoint inhibitors, or at least individual checkpoint inhibitors. And people are now trying to add that to different PARP inhibitors and bevacizumab, Avastin, and the like, trying to do all the above to see if you can't do better even up front during carboplatin and Taxol. Those studies are still underway, and so we don't know the answer there yet. But we are learning more about how to make immunotherapy better. And this is not just for ovarian cancer, but for diseases that are tough to treat at other sites, like pancreatic cancer, prostate cancer, and the like. And it turns out that the cells that you need, the lymphocytes and the T-cell lymphocytes that are there in cancers, but they're turned off or they're exhausted. And we're learning the rules now to get rid of whatever's inhibiting them, to neutralize that, to prevent exhaustion, to have the fully competent, robust T cells that are turned on and killing cancer cells like they should be. For immunotherapy, I think that there are real rational approaches that are being tested, and more will be tested, to see if we can't improve on the use of the immunotherapies that are available. There also are other kinds of immunotherapies that are being developed. CAR T cells, CAR NK cells are dramatically effective against cancers of lymph glands. It remains to be seen how effective they'll be against solid cancers like ovarian cancer, but that hasn't really been adequately tried yet, and they might be very effective. So I'm optimistic that with better targeted therapy, with better immunotherapy, possibly with more early detection, if we can get it right in terms of the CD125HE4 and whatever, that we really might be able to get a larger fraction of patients where the disease never returns. And I think if you do computer modeling and figure out how many low-grade cancers, how many high-grade cancers, what would happen if you detected them earlier, the estimates are between 10 and 30% reduction in mortality. I mean, flat out cured if you could just get the screening tests effective. And so that's what keeps us going, to really try to do that. and really try to provide that for women with ovarian cancer, so that they could using the treatment we got right now today, could really cure 10 to 30% more patients than are currently cured.
My message is stay optimistic. I'm super optimistic. There's a lot of hope. A lot of people are working on this with all they have. So we need to keep up the spirit. Don't let the disease or anything get you down, because as I said, I think science is advancing at pace which is, really beyond control in some ways. If we can channelize even parts of this in the right direction, we will get to this in the near future. So I'm very optimistic. In fact, I have to be optimistic with what I do, because otherwise it becomes difficult to do what I do. But I would just tell you all that stay hopeful, stay optimistic. We'll all get there together.
I'd kind of give you a historical perspective, because for me, I still find it incredible what's happened. In 2000, so 20 years ago, I was a wet behind the ear postdoc, just starting out in the laboratory of David Livingston. And David Livingston at the Dana-Farber really gets credited with the understanding that we've developed over the years of how the BRCA genes work, right? Which is that they are involved in maintaining the integrity of our DNA, right? They are involved in DNA repair. And I remember clearly having a conversation with him in 2000, asking him, well, the BRCA genes are tumor suppressors against breast and ovarian cancer, and yet everybody in the lab works on breast cancer. How come nobody works on ovarian cancer? And he said, look, the reality is we don't know enough about it. We don't know really where it starts. We have no early detection. There isn't enough money in it. And, I kind of asked him, well, would it be okay if I sort of try to dabble in some things I thought was interesting? He was like, absolutely sure. He was always very generous in that. But he was right, because back in 2000, we didn't have these organizations, right? There was the Concert for the Cure of Breast Cancer, the Race for the Cure of Breast Cancer, all these other things that were going on for breast cancer, very little in ovarian cancer. And I now look over the last 20 years, and I've never seen as many researchers involved in ovarian cancer. I've never seen as much money or awareness. It's pretty amazing. And I think this is the most exciting time in the field that we've seen in decades. And we're starting to make progress in all the things we've talked about, right? Early detection and prevention and therapy. I mean, like we literally have new drugs now for patients with BRCA mutations, for patients who get ovarian cancers. We're really evolving our ideas about early detection and prevention in ways that, in 2000, we had no clue where this was going to go. So I think it's a very exciting time, and it's been kind of going up on this sort of exponential growth curve. And I also give a lot of credit to organizations like Overcome, because it's a lot of the grassroots efforts in terms of the education and awareness that leads to more funding, that leads to progress, comes from that. And so I think it's a very exciting time. And I'm looking forward to, in the next 5-10 years, even making more progress so that we give patients better opportunities, better choices, better treatments for this disease that has historically been, a lethal disease.
Well, I would just say that I am inspired by people who are diagnosed with ovarian cancer, inspired by their journey. I'm inspired by just the range of how people address this very serious condition that impacts not just their lives, but the lives of their families and the entire communities. And it is inspirational to work in this field. It is what drives me every day. And my hope and my actions are that we can do something to continue to make a difference every day. And that the people involved in Overcome have just been so incredible and are leaving large legacies by their actions every day for other women who are diagnosed. And I think that the voices of people diagnosed with ovarian cancer are really critical to other people who are coming along the way. Even, because firsthand knowledge and the lived experience, I think is so important and helps in ensuring that people are getting the care that they need.
Say you all are so much stronger than you give yourselves credit for. I am just absolutely amazed by all of the women I have the privilege to treat for this terrible disease. You're amazing individuals. I am, as your oncologist are so proud of how you do this. We are here for you. We are partnered with you. And please know that you've got a whole team of advocates who really, really want the absolute best for you. So I want to thank you because I learn every day from you, and I feel it is an absolute privilege to care for you every day.
I think it was very comprehensive. The other thing I would say is that, again, I started with saying education is power, like having the knowledge would definitely allow you, having a knowledge about your body, your organ systems, and you don't need to be a doctor to know all the details of the organ system, but you need to generally know your organ system and what your normal base is. And then also there are great resources. So internet is a great source. There is some misinformation and there's some great information. Going to the website that you guys provide, also American Cancer Society, SGO, Society of Gynecologic Oncologists, WebMD, Mayo Clinic, even Hopkins. There are so many different websites that provides you all this basic and more advanced information that you need to know, knowing that everything you read does not mean that you have the symptoms or you have the disease. However, it helps you recognize those symptoms. And the best thing would be you go to a doctor and it's a false alarm. And that's that. Secondly, I would say establish a good relationship early on as a young woman with an OBGYN and somebody you would trust, somebody who would listen to you, somebody who would take your concerns very seriously. And in that sense, it would keep the health of the reproductive system kind of in check. And from that, usually, in the field of OBGYN, most of the OBGYNs are knowledgeable enough to kind of help you with your overall health. And if there are concerns, then they can refer you to the specific specialist.